let's look at how we can take trigonometry and apply it to right triangles. So we will be looking at solving a right triangle. And whenever we talk about solving triangles, we are going to determine all unknown angles and all unknown sides in that triangle. So a couple key things that we can remember from geometry in solving triangles is that the smallest angle is always going to be opposite the shortest side of our triangle. The largest angle is always going to be opposite the longest side. And remember that the sum of the angles in a triangle is 180 degrees. So here we have a right triangle and we are asked to solve it. What I typically do in a problem such as this is I take inventory of all what I've been given and what I need to find. So let me go ahead and label the angles. So I find the right angle and the hypotenuse and I label them C, a capital C for the angle and a lowercase c for the side. And then what I have left is A and B for our remaining angles and sides. So it doesn't matter which one is which at this point. So we can call this A, that would be the angle, and then a lowercase a for the side, which means this angle will be B, and the unknown side will be lowercase b. So as we take inventory of what we've been given, we know that we have sides A, B, and C, and angles A, B, and C. We know C is 90 degrees, angle C that is. Angle A is 10.2 degrees. And we know that side A is 38.5. So we know that the sum of the angles of the triangle must be 180 degrees. So A plus B plus C must equal 180 degrees. That means that 10.2 degrees plus B plus 90 degrees must equal 180 degrees. This means that B will equal 79.8 degrees. So let's go ahead and label that on our diagram. And then we also know that we can fill that out in our chart here. And that's exact, so 79.8 degrees. Now it will be left to find sides B and C. So we know angle A, and we know its opposite, and we need to find the hypotenuse. So we know sine of A should equal A over C, which means that sine of 10.2 degrees should equal 38.5 over C. If we go ahead and multiply both sides by C, we'll have C times the sine of 10.2 degrees, which is equal to 38.5, which means that C will equal 38.5 over the sine of 10.2 degrees. If we now use our calculator to evaluate that and round to 2 decimal places, make sure that you are in degree mode. That yields for us C will be 217.41. So if I go over here and I fill out the chart, C is approximately 217.41. Now it's left for us to find B. But to find B, we know angle A and B will be adjacent, and we were given opposite, so the trig function that relates those three quantities is the tangent function. So the tangent of A should be A over B. This means that tangent of A will be tangent of 10.2 degrees, and A is known to be 38.5, and B is unknown to us. So this means that B will equal 38.5 over the tangent of 10.2 degrees. Using our calculator in degree mode, we should obtain B to be 213.97. So B is approximately, in our inventory, 213.97. So a couple things that we can double check. Make sure smallest angle and smallest side correspond, and largest angle, longest side correspond. Middle angle, middle side. Now let's take a look at a word problem. The sun is 18 degrees above the horizon, and we are supposed to find the length of the shadow cast by a tree that is 26 feet tall. So let's go ahead and draw a picture. So there's the ground. We don't have to be too fancy at this. There's the sun. Now to draw the tree. So now the tree is casting a shadow caused by the sun. So the shadow would have a length. In this case, we don't know that length, x. We do know the height of the tree is 26. And we'll assume that the tree is perpendicular. And now we have our angle that's 18 degrees. And we can use the tangent function, which would relate these three quantities. So we know that tangent of 18 degrees should equal opposite, which is 26, over adjacent. So this would mean x tangent of 18 degrees would equal 26 by multiplying both sides by x. And so x would equal 26 over the tangent of 18 degrees. And so x, let's approximate this and make sure that our calculator is in degree mode. And this is about 80 feet. So what's the length of the shadow? The length of the shadow is 80 feet, is about 80 feet.